Suppose the spheres A and B in exercise 1.12 have identical sizes. A third sphere of the same size but uncharged is brought in contact with the first, then brought in contact with the second, and finally removed from both. What is the new force of repulsion between A and B? This is an important question. Listen to this. So initially, if I take the charge to be Q here, and if I take the charge to be Q here, right? So first of all, tell me what is the value that was obtained in the previous case. So what is this value? 4.5 into 1.5 into minus. Okay, let's remember this. Now listen to this question. So there are charges Q and Q, which is considered to be A and B. Now there is a third particle which is uncharged. So if C is brought in contact with A and then moved, then the charge will get transferred in such a way that the sum of both the charges is what you need to do, divided with 2. That is the average of these two charges, right? So now C has got how much charge? Q by 2. Now what is A left out with? A is left out with Q by 2, right? Now this Q by 2 is taken in contact with B and removed again. So what will be the new charge that will be available? It will be Q by 2 plus Q the whole divided by 2. I told you, you need to take the average. So Q by 2 plus Q the whole divided by 2, it will become 3Q divided by 4. Right? Then how much is the charge that is going to be present here? It will be the same thing. No? Okay. So what is going to be the new force of repulsion between them? If I call it as F double dash, then it is going to be K multiplied with the new charge Q by 2 on A and the new charge 3Q by 4 on B, the whole divided by R square. Distance is the same, right? So this is going to be 3 times K Q square divided by 4 times R square, not 4, it is 8 times R square. So it is becoming 3 by 8 times F. So it is going to be 3 by 8 multiplied with 1.5 into 10 power minus 2. So when you calculate this, that will be the required answer. Is that point clear? Right? See, this is a very important thing that you need to understand. Is everyone clear with this? You need to take the average of charges. So figure 1.33 shows tracks of 3 charged particles in uniform electrostatic field. Give the signs of the 3 charges. So the first charge, second charge and third charge. So first and second are negative and the third one is obviously positive, right? Which particle has the highest charge to mass ratio? So the answer to the second part is E by M ratio, or I'll write it as Q by M ratio, is highest for the charge which experiences maximum deviation. So Q by M ratio is the highest for the charges which experience maximum deviation. So which one is experiencing maximum deviation is what the question is. So how to do that is, in your textbook itself what you can do is, the horizontal path is there, no? Draw an extended line like this and see which angle is more. That one will be the answer. So initially it is having a horizontal path, no? So which one is experiencing more deviation? That's the answer. Check. See, why is it so? Actually, the answer to that question is given in the 33rd question. Look at 1.33, no? 1.33, the next page. So there, you're able to see one expression, QEL square divided by 2Vx square, I think. So that is actual reason why the charge by mass ratio is directly proportional to the deviation. But as I told you, we'll not be doing the additional exercise problems. That's why I didn't go into the mathematical details, but I hope you understood this. Consider a uniform electric field E is equal to 3 into 10 power 3 I cap Newton per Coulomb. So write this as E vector. Right. What is the flux of this field through a square of side 10 centimeter on a side whose plane is parallel to the YZ plane? Suppose you have a square like this, right? As understand, this is x-axis, y-axis, and something towards you is taken as the z-axis, right? There is an electric field existing in this direction, right? Now, there is a square whose side is parallel to the YZ plane. So, this is Y plane, sorry, this is Y axis and this is the Z axis. This both put together will give you the YZ plane. So, there is a square placed like this and electric field is like this. So, when a square is parallel to the YZ plane, its aerial vector is along the x direction. Are you able to visualize it? So when there is a difference here, whenever they say a plane is, whenever they say a shape is oriented to a particular plane, its aerial vector will always be perpendicular to the plane. To put it simple, you have x, y, z in the three-dimensional space. If something is parallel to YZ plane, its aerial vector will be in the x direction. So if I have suppose xyz, if suppose the question says something is parallel to xy plane, then its aerial vector will be in the z direction. So in this problem, what is happening? So aerial vector is going to be equal to, the side is 10 centimeter. So it is going to be 10 into 10 power minus 1, the whole square times I cap meter square. Am I clear with this? Sorry, 10 into 10 power minus 2, the whole square, I cap meter square. So it is going to be 10 power minus 1, the whole square is 10 power minus 2 times I cap meter square. So what is going to be the flux value? Flux is equal to E vector dot A vector. E vector is 3 into 10 power 3 I cap dot A vector is going to be 10 square I cap. So answer will be 3 into 10 power 5 Newton meter square per Coulomb. So this is going to be the flux in the first case. Is that clear? So this is going to be the flux in the first case. Harini, what is the doubt? You're clear? Is there anything that is not clear? Which part did you understand? Did you understand? Are you able to visualize the question? No. See, there is a uniform electric field in the x direction. You have, let's say, there is a field going like this. In that field, they have placed a square like this. And how is that square? The plane of the square, how is it? Whose plane is parallel to YZ plane. So the square's plane is parallel to YZ plane. So how is its aerial vector? So that is why aerial vector I took the magnitude. Why did I take this magnitude? Because it's a square for the. So initially it was like this. Now it is making 60 degrees like this, so that the electric field is still like this. Electric field is in this direction. When they say normal to the plane, they are indirectly speaking about the aerial vector itself. When the normal to the plane makes an angle 60 degree with x-axis, the aerial vector of the plane also makes the same angle 60 degrees with the x-axis. So to put it simple, the diagram will look like this. If this is how the paper is, right? This is how the electric field is, then this is how the aerial vector will look like. Then how much is angle? So what is going to be the flux? Flux will be equal